My standard disclaimer, give you a little bit of an intro to UPnP in general, then we're going to talk specifically about internet gateway devices. I'm going to run you through a bunch of demos, talk about why this works, and then talk about future research. So, standard disclaimer, this is my research, it's not sponsored by my company, it's sponsored by Big Brain Labs, which is me. If you break something, it's your fault, I'm not going to be held responsible. And we're going to try not to harm any routers here, although I blew up one already. So what is Universal Plug and Play? Universal Plug and Play is a protocol that was developed by Microsoft and a fair number of large vendors back about 8 years ago to help in automatic configuration. Apparently consumers can't handle setting IP addresses and they can't handle setting up firewall rules. So someone decided it would be a brilliant idea to allow the software to do it for them. And as part of that, they invented a protocol called SSDP, Simple Service Delivery Protocol. There's a number of these auto configuration, auto discovery protocols out there, Rendezvous. SSDP is kind of the Microsoft variant, which again, you're going to find in most wireless routers. Devices in general that speak UPnP are required to support DHCP or automatic address selection using the reserved space Microsoft provides. It's based on entirely open standards. So we're looking at your normal TCP and UDP traffic. We're looking at multicast. It uses basically HTTP over multicast in the beginning, but for all intents and purposes, it's a standard HTTP client making SOAP requests. So why is this interesting? We want to find targets. We want to find devices that are out there that are willing to bend to our needs and make changes to themselves. So how does that work? SSDP uses the multicast address that's on the board, 239.255.255.250 on port 1900, and it has two specific mechanisms for discovery. The M search query, which is basically initiated by a control point, such as my laptop, or if you have audio-video networking, you may have a more advanced device that does discovery. And you basically send out a search packet, and you say, I would like a device of this type. Are there any out there? All multicast devices are supposed to respond back with what services they provide and how to talk to them, which is the location URL. The other thing that you can do is you can sit and passively just wait for the devices to announce themselves. It's not a requirement. They're really only supposed to do notification when some state changes within the application. In practice, these devices blast your network every couple of seconds telling you that they're out there. They're more than happy to provide services for you, and these are all the things that they can do. So this is what a typical M search packet looks like. What I have is I have my inside host on 1.100. It makes a request out to the multicast address, and out there I have a standard Linksys router sitting at its default IP address of 1.1. And I'm going to say, I would like, in this case, any UPnP device. So the code I'm going to show you later allows you to do more granular selection, but this would respond for anything that you have that speaks UPnP. Routers, AV players, supposedly there's heating and vacuuming units out there that do it. And I'm asking to do a standard discovery. So what's going to happen back is after that multicast packet, I'm going to get a unicast response back from each device. And the devices love to tell you everything about what they are. So as you can see here, I'm being told exactly what OS version this device is running. I don't know what this one is. This might be a D-Link router. What address to contact them at, and then some other information about how they want to be spoken to. The USN that's provided there is in case you have multiple devices of the exact same class with the exact same name, so that you can still find them uniquely. So, or like I said, I can just sit on my butt and wait for a device to come to me. So this is the same device. It's been sitting out there for a while. And what it looks like from this packet is it was just telling me it's alive. It's ready and willing to receive packets. So I got a location. Now what do I do with it? And this is where we come down to standard web service protocols. I pulled the location URL. The location URL is an XML file with a fair amount of detail. Every service the device provides, and we'll talk more about the IGD profile in a minute. Every service that it provides, what classes of device it is, and then these 5 tags, which are kind of the most important for this conversation. The type, the ID, where the control point is so that I can speak SOAP to it. And then the event sub-URL, which I'm not going to use in this demonstration, but basically you can subscribe to these devices and tell them that you're interested in knowing anytime there's state changes, and then they'll send you messages for any change that occurs, such as network up, network down, rule changes, etc. And then the bottom one is the most important for learning how to speak to a service. So this is UPnP's equivalent of WSDL's. It isn't. I have to write a parser for it. It's a relatively simple language. But this will tell you every method, every variable, what they expect, and conversely what they don't expect to talk to a specific service class. So what do we do now? We're going to grab the URL, which we just talked about. We're going to parse out the actions. We're going to send some SOAP messages, and we're just going to have fun with it. So what do we want to attack? Home wireless routers. So I have a standard Linksys router right here. This turns out to work on almost any router out there. When I was doing this research, I went out to the store and I bought 10 brand new routers off the shelf. All 10 of them had UPnP active by default. And then as we go through some of the flaws in the design of the routers, you'll find that all of them had deficiencies that make it very difficult for a consumer to deal with the behavior of these devices. So UPnP, and specifically IGD, is for simplifying internet connectivity. So I plug in my router, I just want it to work. Stores were having trouble with customer support. I bought my router, it doesn't work, I don't understand, it was costing me money, devices were getting returned. So we simplified it. We let the devices do it for us. And the crux of the problem is any device can request an inbound port forward on your wireless router with no authentication. So I don't think anybody's going to let me log into the router. I'm going to assume that you all change the default username and password on your routers and everyone else that you knows. So I'll do it myself. And this is simply how it works. Within the profiles, and if we have time at the end, I can show you what some of these profiles look like in XML. There's 2 specific sub-profiles that both provide a function called add port mapping. This is default in the protocol. If you go and read the spec, there's an RFC that never went further than an RFC. You have a WAN IP connection, which would be your standard Ethernet, or a WAN PPP, which is usually any form of DSL. There are some devices out there that this profile exists in modems. A lot of them don't bother with that profile, and they just act as IP connections. But all I need to do is I need to send the properly formatted SOAP message with what host I want to connect to, what host I want to allow the connection from, and the ports that I want to do it on. And what I'm going to do is I'm going to give you a simple demonstration of what that looks like using this default out-of-the-box router. So this is my setup network. I'm going to be using my laptop as the inside and the outside. I have a wireless router in the middle, and then I have an external host, which I'm going to show you can connect through the router with basically a couple of packets. So, like I said, I have 2 VMs running on my system. And still have mouse problems. Does anybody have something non-shiny? A flat piece of white paper? All right, that's better. So while I reboot these 2 virtual machines, I originally got interested in this because consumer devices are something that we as security professionals have a habit of not looking at as frequently as we should. But we all have users who work from home. We are all worried about an attacker coming into our company, and maybe leaving a device around. Consumer devices are cheap, right? I don't want to walk in and have to leave a laptop in your business to perform an attack on your business. So what I'm going to do is I'm going to look for the cheapest device possible. A $50 consumer router is a throwaway device. This attack class is really based on hitting home users at home, but the reality is you can perform, using different types of devices, attacks against businesses by changing the configuration on these types of devices and leaving them in the office. For 10 wireless routers for $50, I can throw away. If I get one successful attack by leaving it, I'm good. In this case, what I'm looking for is I want to get in, and maybe after the user disconnects from their VPN, I still have access to their Samba shares from the internet. So as these continue to boot, so in 2006, and if I have time at the end, I'll show you another variant that also used UPnP. We're finding a lot more devices like AV players are using UPnP and variants of it to boot off of the network and receive their system images. So an extension of this, which I did in 2006, was actually subverting the boot process of a wireless media adapter to turn it into a Kismet drone. And if there's time, I'll actually show you a couple of slides from that. I don't have the device with me, but we'll see what we can do for you. So I should be just about up here. All right, so on the bottom will be my inside host, and on the top will be my outside host. And we won't have to reboot the VMs again and waste time. All right, so on the outside, I'd like to get into the inside network. Recall that my inside network, or the outside interface for this device is actually 5.100. So I'm just going to try to telnet to the outside interface on the wireless router on port 1234, which is the port I'm going to be using for this attack. So on 5.100, 1234, right? Standard drop packet, this is going to hang, this is going to time out. So now on the inside, I'm going to send a couple of quick UPnP queries, change the device's configuration, and then show you what actually happens. So on the inside, I'm going to run my little demo script, demo 1. Right, and what demo 1 is going to do is it's going to show you adding a port mapping, and then it's just going to start a little test server, which is going to respond back with a banner showing me I was successful. So when we run demo 1, it's going to go out, found a UPnP device, specifically an internet gateway, which in the code, which I'll show you later, I specifically asked for this class of device. It was available at that URL that you see on the screen, and I sent it an add port mapping for 1234 from any host on the internet to the device on the inside. So now if I go back to the outside and I telnet back to the host, I fail. So live demos are wonderful. So I have videos if this doesn't work. I'm prepared for once. So let's run demo 1 one more time. All right. Telnet 1234. There you go. Now I'm successful. You see hello from and the IP address I connected to and the port I connected on. And if I run it again, instead of a drop packet, I should get a refused. You can see I got a refused that time. I can go back on the inside. I can rerun the test server. And I should be able to do it again. Okay, and there you go. So less fail, more good. So what just happened? Simple discovery, and this is, as part of this, I'm going to be showing you a UPnP toolkit that I wrote called UPnP. It's written in Ruby. It's meant for tab complete exploiting of UPnP devices. I've tested it on IGDs. I'm starting to test it on AV media devices. Always going to be looking for more devices. It is in active development, although I forget to update the website all the time. So I send the discovery packet looking for an internet gateway device. I ask it for its WAN connection IP, and then I send add port mapping. I say 1234 on TCP port, forward it to 1234 on a specific host, and I gave it the nice comment UPnP. Is this bad? I think so. I didn't show you guys authentication because there isn't any. In the web interface, there's no way to turn this off, which I'll show you in a little while. I can turn off UPnP as a whole, but I can't turn off and say only these specific applications are allowed forwarding. No authentication, no user notification. My laptop had no clue this happened. The inside host had no clue this happened. The logs generally don't show this happened. And even worse, any computer on my network can request on behalf of anyone else. So if you've got these devices in your small business and you get infected by, say, a worm or a malicious user, I can request a forward on anyone else's behalf to any system. And it gets worse. So anybody on the inside, it's only supposed to be on the inside, and it turns out of the 10 routers I looked at, 6 of them allowed me to forward anywhere on the internet. You look at their source code, they define internal host as 0.0.0.0. Not a smart idea. And I can do things like forward the admin interface. This makes it easy for me to go in and change the router and disable any other functionality I don't like. Default router, port 80, stick it on the outside, have fun. So, or I can just do simple, stupid denial of service. Turns out if you fill the forward table, most devices will tell you they're accepting rule changes, but they won't. And they'll stop forwarding packets in a lot of cases. It depends on the implementation. Part of my research in gathering devices is trying to actually map some of the different UPnP stacks and their behaviors, because each device seems to have different behaviors. Nobody followed the standard or lack thereof. So what are you going to see on your router? So recall I just added 1234 as a port forward. So I'm going to go and I'm going to show you what the Linksys router actually sees when I do that. So if I connect to its default interface as admin, right? So you would go and you would look at your application and gaming rules, right? This is where you would set your forwards manually. There's nothing in this interface. Most devices won't show you anything in the interface. If I look at the port triggers, there's nothing in the port triggers. If I go and I look at logging, which is under the administration tab for some reason, it's off by default. So let's go ahead and let's turn it on and let's look at the incoming log. There's nothing there. So we'll go ahead and we'll add another rule. So when I run demo 2, I find the device again, I list the rules that are on it already, I go ahead and I add a new rule forwarding 6666 to 1234, and it's not going to be, it's going to show up here, so I obviously have the rule added. If I go and I refresh, there's nothing shown there. So if I go to the outside, sometimes it'll show it, sometimes it won't, but I'll connect through after I start a test server. All right, so I'm going to connect to the same device. This time on port 6666. Right, same thing. I had success. So if I go here and refresh, it doesn't show up. Apparently on a Linksys router, and I found this out after the fact, I actually have to save the settings, even though I can look at the log right away, and continue. And then if I look at the incoming log, it's still not there. And again, this is a connection log, so it doesn't actually show you that the rules have changed. But the only way a normal user who's not going to go through that much trouble to find the logging information is going to know someone's connected is if they happen to have logging on and the connection hasn't aged out, but even with logging on, it's still not going to appear anywhere in the application configuration for forwarding. So, not knowing that you have firewall rules allowing inbound connections to any port on a host on your internal network, I think it's bad. I think most of you probably think it's bad too. Most users aren't going to check this. These are home users. Home users plug in a device, they leave the device on, they hope it works. If it stops working, they unplug it, they reboot, and they hope it works again. If you check it, you're still not going to know that there's anything wrong with it. And you know, my mom doesn't know how to use Nmap, and I really don't feel like doing it for her. So this gets a lot worse quickly. Luckily, not all devices do this, but I found 2 out of the 10 that I looked at that will persist the rules to flash, the rules that you can't see in the web interfaces. So if you can't see them, how are you going to change them and how are you going to remove them? If I can fill up your forwarding table and you can't see the rules and you can't remove them and now you can't receive packets, how are you going to use the device? You're going to reset it, you can throw it out. And my favorite is there are devices that will show you these rules, have administrative interfaces for dynamically editing rules, but don't know how to edit UPnP enabled rules. And there are no default tools out there for helping users speak UPnP to make the rule changes themselves. So, can we do anything about this? Turn it off. You really don't need it. There's very few applications that actually legitimately need this, and most of them have workarounds. Chat clients are one of the applications that tend to want to use this so that you can send photos to your mom. Things like AOL have rendezvous servers. If UPnP doesn't work, they can still send the picture. They just go through AOL. Xbox Live uses it to some degree, but it has some workarounds for it. The only thing that for this crowd might be legitimate are BitTorrent clients, but if you don't know how to forward an incoming port for BitTorrent, you probably shouldn't use it. Don't forward on behalf of other users. This is stupid. I see no valid reason for this. The protocol doesn't specifically allow it or exclude it, but allowing any device on your network to ask for a forward to somebody other than itself seems like a blatantly dumb idea to me. So we could modify the servers. I don't think this is a reality, although I actually found one portable router that allows me to say who I'd like to accept port forwards from by MAC address, which is actually kind of cool. But the other routers other people have looked at for me don't have anything like that. It might break the spec, but I doubt it's going to matter to anyone because the reality is I haven't found a legitimate application that asks for a forward on somebody else's behalf. Implement the security profile. So the people who invented UPnP 6 months later actually came out with a security specification. The UPnP spec is about 11 pages. Security spec is 100. I gave up reading it after page 60. It's bastardized PKI at its best. And I can understand why no vendor has implemented it. So then there's some other variants. We could use just a basic keyed URL. So the attacks I've shown you so far are internal only. This doesn't have to happen internally only. Restricting to some secret, even though this is done in clear text, is better than nothing. We should really have to authorize the devices and the applications that we want to do this on. If we put on SSL, then we can't just steal the keys by listening to the network either. Again, would require modifying the UPnP clients and servers, and it's probably not going to happen in reality. Stop buying the stupid devices, or at least find a vendor who turns it off by default. Again, brand new routers. I bought another one last month. I still haven't found a device that has this off by default. DD-Wart does, but nobody sells DD-Wart routers in consumer stores. So this gets much scarier. UPnP loves to invent dumb things to allow your computer to do. Changing your DHCP relay, your next router, or your DNS server, all bad. Any one of these, I own the network. Any one of these, no authentication. I'm amazed no worm or virus has actually done this yet. You know, someone is. Gets even worse. So the DSL profile, which say 40% of the devices I looked at actually support, 2 of those devices actually allowed me to ask the device for its username and password. Not for the device, but for the actual DSL account. These are things that are given out by the DSL providers with this functionality on the inside interface, and some of the providers are using email address as a username, and some of the providers let you set your password. So my email address and my password as a normal consumer are usually the same ones I use for Amazon, my banking account, anything else I have access to. Anyone with one packet can request the username and the password of the device, and then go use it for DSL or to get access to whatever else that account has access to. So, yeah, the implementations suck. Most people use the Linux IGD code. It's the default code for the Linksys routers. It's using system to call IP tables. It doesn't do proper parameter checking. So you can do simple things like run, sbin reboot. I'm working on a remote reflash using this. I don't have it quite working yet, mostly because I don't have the hardware to recover if I get a bad flash. But you can run anything on the file system with this. This is patched on current Linksys routers. This obviously doesn't work on the VxWorks variants. But in reality, you'll find that most people install a wireless router and they never replace it unless it catches fire. So they have old code vulnerable to this style of attack. So it's a small computer. It's got a web server. It's got every classic flaw you're going to find in a desktop or a server, but it doesn't get patched, ever, right? I mean, how many people have patched their home routers? I'm going to assume most of you. How many people have gone over to their parents and patched their parents' routers, their grandmother's routers, right? Their neighbor's routers, right? This just happens. And they have file systems. You can write to some of these file systems using simple flaws like system exploits. They have buffer overflows. I found one that had a format string. Format string, you don't even need to debug it. You just need to get creative, and you can write the exploit remotely. It takes a little bit of time. And it doesn't have to be local. So the guys from GNU Citizen are here. Hopefully, I don't know if they're talking about it or not. I didn't actually see the slides. But they came up with an interesting way to do this blindly using Flash. Basically, the location URL I showed you before stays pretty static per device. So every Linksys router seems to use the same service URL. You can't do the multicast to do the discovery, but if you just raw connect to that URL and that port and send a properly formatted SOAP request, you can change the firewall rules on it blindly. Cross-site scripting, request forging, any of the other browser variants, users are at home, they're using browsers. If you can send a request to the device on the known URL, which most people have a Linksys or a D-Link, you're going to win. Obviously, any worm or virus. And my personal favorite, one major internet provider north of Maine, I'm in North America, puts UPnP on the WAN interface by default for no good reason. So how am I doing all this? I'm going to show you guys a little bit of the code that I'm releasing with this. It's called UPnP. It's written in Ruby. The goal is to actually integrate it into Metasploit when I get a little bit more time. It's going to allow you to do tab completion when you work with these devices. I'm going to show you a little sample script, and then I'm going to run it and show you that we can query a device. I doubt anybody has a Linksys router here, but or any router here at this point. But if you do, bring it to me afterwards, and I'd love some more data points. So let's look at demo 3. So this is the simple Ruby code. It's only a couple of lines. The majority of it is in these two libraries that I wrote, UPnP and SSDP. The UPnP library is more complete. It's the one that's going to allow you to do the actual interaction, handle all the parsing for you, and dynamically build objects that only have the methods that your device provides. There's actually a stub generator, so if you want to generate full stubs, you can actually download the specification files right from upnp.org, run it, and it'll give you static classes so that you can send whatever type of data you want in case you're trying to develop an exploit against a specific UPnP stack. SSDP really does the discovery. I got lazy here, and it just does discovery. There's some other creative things you can do. I'm going to add event handling so that after you root a box remotely, you can have it send you any event changes to any address on the internet if you want. But I'm kind of lazy and didn't need it for this presentation. So what am I doing here? And then I'll run it for you. I'm basically just going to declare a new SSDP discovery. I'm going to ask it to find me the first router that exists. This is the default. You can override these. I'm going to find, that's going to give me a specific host. I'm going to set its location URL, load the XML data that describes what the device does, parse out its services. In this case, I am going to be working with the IP connection, which I showed you, but we can change service classes, and it looks like I have a little bit of time, so I'll probably do that for you. Then I just activate each service and can do basically whatever I want. So I'm just going to run the first couple of lines for you. So it's my inside host again. Recall we have 2 port forwards already in existence. So for those who know Ruby, I just use IRB. I'm working on, like I said, getting into Metasploit, probably as a tool module. When that code gets written, you'll be able to use the full Metasploit framework with it. So paste in my code. All right, that's mostly the Ruby debugging. So now I have a service object, and I can ask it, what actions does my device provide? Or if we want to make it look a little bit prettier, right? Here are all the functions in that device class that are accessible to me right now, and only the functions that are accessible as opposed to the full spec. So I can do things like ask it for its external interface. Right? Tab completed, of course. And ask it for, let's see what other GET requests we have. It's connection type. The connection type, and unfortunately it's not in these slides, but I've been asked this before. This device only supports IP routed, which is nice, but in addition to the gets, there's a lot of sets, and you can do things like set the connection type to IP bridge mode, which on most routers is the equivalent of DMZ mode. So it's just going to bridge the WAN interface to the LAN interface, and any packet sent there is going to end up on the inside. So you could do broadcast attacks or whatever else you can get at that WAN interface will pass right through. If you're lucky, the device is inside, we'll just request new IP addresses and all become exposed on the internet if your cable provider allows you to get more than one IP. You can do really annoying and creative things like, I think this device supports it, forcing connection termination, which will annoy users to no end. If you send a forced termination, the device will drop its WAN interface connection immediately. You can request it instead, and then it'll give a small timeout and do it. But when the user goes to check it, it's going to reconnect automatically on most devices, so it's not going to be very easy to debug. If you have a little script running, this goes on all day. So you can get status information, you can get uptime. This device doesn't support the full spec. There's a lot of other things that you can do. If I switch service profiles, I could show you things like the generic higher level profile called IP connection allows you to check the state of the device. Some devices actually have extensions that allow you, if they have multiple NICs, to reroute which NIC is which, so you can switch the WAN interface and the LAN interface. Or if they're like dual cable modem modems, you can switch which one's the primary and the secondary. So let me break out of IRB and show you that I also am providing code, just UPnP or UPnPwn. It's a Ruby script that lets you do the simple manipulations without actually having to go through and write the actual Ruby code. So what I've been showing mostly is the list functionality. It looks like we have a little bit of time, so what I'm going to do is I'm going to show you what you can do if you want to do research, and I'm actually looking for people to send me the dumps that I'm going to show you. So I can ask UPnPwn to give me the XML from any device that's out there. Oops. So let's actually look through it real quick, because I don't remember the command line parameters. So here's kind of the functionality I provide out of the box. README sucks, read the source code, it's commented. So out of the box, I can add port mappings, I can specify a URL. I designed it so you can run it on the files offline in case you have a data capture and you want to see what a device would have been capable for. So getting the WAN IP, I added because the last time I did this demo, I forgot the WAN IP. Get credentials will give you the username and password from a device if it supports it. One of the interesting things I found is devices that support get username and get password don't always support it if you're in Ethernet mode. They typically only support it if you actually have PPP enabled, and they might not give it to you unless you've already established a connection. I don't know if it seems to be more than one stack behaves that way, and it seems to be that sometimes the devices require a reboot before they're in that mode. But generally, the PPP interface still sticks to pretending to be an Ethernet interface and doesn't do it. But a lot of actual DSL modems will do it by default. All right, so if I ask for information about the device, and I'm going to dump the XML, I'm going to get a full parsing of everything this device supports and the XML. So this device has 3 service interfaces. I'm going to get a list of the control URLs for each one, where the description files are, the actual XML for the descriptions. And if I keep parsing through it, I get dumps of any actions that are supported by the devices. So right up in here, this device has 15 actions for the WAN IP connection profile, which again, I showed you in the code. So moving forward a little bit, what I can do is I can show you, and this is what really scares me, how helpful other devices are that have learned that UPnP exists. So luckily, I brought a video of this because apparently American Power adapters with the wrong voltage converter equal lose. So I videoed this, and I'll do my best to narrate it because I videoed it a little while ago, and I don't remember exactly how it went. So this is this device, which luckily didn't also catch fire. It's a Ethernet-enabled webcam. Cost me about $80. Pick them up. This is a generic one from Airlink. You can pick these up in most stores these days. A lot of them are running about $200. People love these for monitoring their babies or putting in other places. So let's run demo 4, and hopefully we can see it at this resolution. ActiveX rules. All right. So what you have here is the same thing, the outside host and the inside host, and it's going to be a demo of how helpful gadgets can be. So I wrote this little watchdog script, and I'll talk about some of the other countermeasures that I haven't talked about yet. Nobody seems to do it, and I really wish a virus vendor would do this. Actually monitor for changes to your rules. So I'm going to plug in the gadget with typo and all. And we're just going to keep watching what's going on. So you give it a couple of seconds. This is a default device. I actually found this by accident while talking to somebody else instead of coding. And I think it's this time around. Nope. One more time. Basically, there you go. The device decided to add port 80 inbound to itself. So now my Ethernet-enabled camera is accessible and Google indexable. So I'm going to log into it. Again, I haven't changed this device. So default username, default password, which I guessed. I was too lazy to read the manual. Give it a second because apparently I forgot to click OK. And remove the bubble. And there we go. I have a webcam with night vision mode apparently on by default, available to anyone on the internet who wants to look at it. So yeah, night vision. This camera does a lot of other stuff, so let's see what else it does. I could turn off the status indicator so you don't know that I'm using it. Could turn on the microphone. Click. I can set up a subscription so that I send your videos by email or FTP to myself in case I want to watch them on my phone when I'm in Malaysia. It's got motion detection, so I don't actually have to watch it the whole time. Unfortunately, I did this in Firefox. You can take some snapshots. You can do a lot of other random stuff. But again, This is normal. These things are just OEMs devices that have a new sticker slapped on them. So, yeah, that didn't make me too happy when I saw it, but at the end I was like, oh, cool, new demo. And there's my monkey again. So let's get out of this demo. So, and back to the slides. So I was saying before, the little watchdog script, I'm going to make it better. I'm actually going to put eventing into the device so that I get notifications instead of just having to do polling. But this will be a really simple fix, and if there are any antivirus vendors, please do this. I'm giving this idea away for free. Query the device. It's one packet to ask the device how many rules it has. And there's a couple more to get copies of the rules. Tell the users when the rules on their devices change. So what am I doing? I talked about this before. I'm doing fingerprinting. Please, if you have devices, I need access to them. Just run a dump XML and an info and send me the code. There's an email address at the end. So help me actually figure out what's out there, which stacks. I've found about 6 stacks out there. The predominant ones are obviously the Linux IGD, old and new, on most devices. There's another one called UPnP embedded, which I can't figure out the vendor for, but it seems to be on a number of the VxWorks ones. VxWorks also has their own, which is on most of the actual VxWorks design devices. I'm working on a fuzzer, so like I said, I have a couple of routers that consistently crash, but I didn't have a JTAG debugger, so I didn't get to write actual buffer overflows for them. I'm gonna go one step further and write a fuzzer. It turns out, and I don't have it working on the one router I tried, one of my routers will actually display the rule changes, so if you stick weird things in the comment field, like script tags, you can get it to do interesting things like pop-ups. There was some weird formatting. I had to do some double encoding, so it doesn't seem to work all the time. So I'm hoping between writing a fuzzer for looking for exploits and just a fuzzer looking for other things that I can put in the fields, because I made sure that this implementation ignores the spec. You can put whatever you want in it. Please have fun. Buffer overflows, reflashes, this watchdog, which hopefully somebody else will pick up. Windows Connect Now is the next generation. I haven't looked at this yet. I have 2 devices that do it. This is supposed to be the secure version where you actually take ownership with your home PC before you can send rules. I don't know that it's going to work or not. I need to look at it. Down a little bit lower, I talk about there's a heating system apparently UPnP enabled, or that's what Honeywell said in 2002. I can't find one. If you have it, find me. That profile uses similar security but has a unauthenticated reset feature. So you can just reset the device and take ownership again based on the spec, but I can't see one in practice. And I'm obviously going to start looking at Rendezvous and a couple other things. So I'll take a couple of questions now, and then I also have, I could talk through the UPnP device that does bootloading if there's any time left. So any questions? Yes.
Hi, I got 3 questions. Question 1, how do I know my device has UPnP? Actually, I have a couple of 3-COM devices at home, and I don't see any UPnP tabs or radio buttons and such.
Okay, so simple way is run this code and it'll tell you. If you just run it in info mode, it'll do the discovery. What you'll find is, and I don't know the specific device you have, either they have a UPnP tab or they don't. I have devices that have no way to turn UPnP off, which really scares me, but it's on. So simple answer is, as a normal consumer, you don't have a way. If you enable the Windows UPnP tools, at least in Vista, it kind of goes out and it tries to do a discovery and will tell you a device is there. That's another way as a consumer, but then you've turned on UPnP on Vista and you have to deal with any attack against it on Vista. So there is no simple way as a consumer, and that's kind of the problem. So question 2?
Question 2, is there a way for me to turn off my client search for UPnP, say if I'm using a Mac or Linux?
So I don't think Linux does it by default. I'd have to think about that, and I don't have a Mac, so I can't answer that one. On Windows, if you don't install it on XP, it's not there by default, and on Vista, there is an option, but you have to Google for it. It might not be on by default. So the host OS generally doesn't care and doesn't do this. The applications do. So like some of the BitTorrent clients will by default go out and look for a UPnP device just so they can open the inbound port. So you really have to disable at the application level because the OS doesn't need to know this. It's really the applications that do. The OS just tries to be helpful from time to time.
This could be a dumb question. Is there a way that, for example, using stuff like IDP and IDS to detect UPnP, adding rules to my IP tables, for example?
Absolutely. And I probably should add it to my research because I didn't think about doing it. So if you look for msearch packets, you know somebody's doing this. This is so unencrypted, it would be ridiculously simple to just look for add port mapping. If you get an add port mapping sent to your device, it's going to work. And then, if you wanted to do kind of false positive detection, what you can do is, I didn't show it here, but if you look through the code, it's pretty simple to do, or just play with the device. You can request how many rules are there. It's one of the default UPnP methods that every router I've found seems to provide. And then you can ask for a specific rule. So all you have to do is ask for the current count and then ask for the last rule. And if that rule matches what you saw an add port mapping for, there was a successful port mapping sent. So, any other questions?
Hi, do you know this DNLA?
DLNA, yes.
Is it similar to UPnP?
So DLNA is, so the UPnP vendors who did IGD didn't really agree on what they should do, and there's some incompatibilities, and nobody seemed to implement the same thing. So DLNA is really the AV spec. So there's an AV spec called UPnP AV. DLNA is a bunch of vendors got together and said, we are going to implement these features of UPnP AV to support it. It's not in this slide deck. I am researching generically UPnP AV. It's vulnerable to similar things. They're mostly devices that have been rushed out the door based on reference designs. There's one really interesting feature that somebody else pointed out to me the other day in the AV profile. I forget the exact method name, but basically you can send informational messages like caller ID to somebody's TV set if it's doing DLNA as a AV renderer would be the class. So you can just annoy them. You can also send pictures. So in the middle of a movie, if you send the right packet, they have a picture of whatever you choose to show them on their screen. So yes, UPnP AV, same class of attacks. This toolkit will work for most AV devices, but I only have 2, so I haven't done a lot of testing. If you find devices it doesn't work for, send me the dumps. It would be helpful, or better yet, send me the devices because they're more expensive than routers. So any other questions?
Are NAT PNP devices better off?
Excuse me?
Are NAT PNP devices better off?
Are NAT PNP devices? So I haven't looked at the NAT PNP devices, and I haven't looked at like the stuns and the other like rendezvous protocols. I would suspect that most of them, since a little bit of looking I've seen, they don't have authentication methods. It's just a different way of agreeing on a port to share and allowing it to come inbound. So the package you would send would be different. I don't actually have any, but like I'd love to look at those too. I would suspect you can do almost the same techniques. Just find the device, send a request. You might have to forge it in that case, just because of how it works, but send a request on somebody else's behalf and say, I'm about to use this port and the response needs to go here. And I would suspect that it would go through relatively easily. So, anything else? All right, what I'm going to do is I have a couple more slides from the presentation I was talking about that I did in 2006. There's a little bit better context now. When I did this in 2006, I hadn't actually researched UPnP and SSDP at the time. I just kind of figured out that I had a device that had some weird boot methodology. So what I found when I did that was, let me pull up the slides for you. All right. So I created this project, which is also available, I think it's still on my website, called Project Cowbird. And basically what it did was I took one of these UPnP AV routers, or specifically a media renderer, and this is a really old one. They're about $30 to $70, which makes them cool from the throwaway device standpoint too. I figured I'd subvert it. So what I found when I was using the device, it had a ton of hardware in it for 30 bucks. And I got a Prism 2 card, I got video out, I got an infrared receiver, which I kind of have working for receiving V cards if you have a Palm Pilot, so I can just sniff, wireless infrared if I'm pointed at it. I've got flash, I've got JTAG, I've got Ethernet. I can basically do what I want. And turns out the device uses SSDP to announce its presence. So it works a little bit backwards, where a lot of these devices will boot and they'll be looking for other services. So like specifically in like DLNA, what they're doing is you've got renderers and you've got like media providers, and the renderers wake up and they say, are there any providers out there that I can get data from? Well, this one instead says, hey, I'm available, can somebody boot me please? And then it sends like, hey, my boot URL's over here, talk to this service and tell me what I should do. So what I did was I wrote a server that responded to its SSDP request and said, hey, yeah, I'll boot you. Here's the URL I want you to grab data from. And then I send it new data. So this is the perfect reason why you should sign your bootloaders and do something more intelligent with your code. Their boot images are very secure because they renamed CramFS to .img. So I built a custom boot disk for the device that runs the original client code and a Kismet drone. And the new version, which I haven't released yet, now uses UPnP to allow an inbound port so that I can connect to them and announces its presence to a home beaconing server. Because they didn't verify anything, they had no security, and like if you don't want to run my server, you can just modify the XML that tells it what file to boot and give it a new CramFS image. Two of these, a router, all the power plugs fit in a soft-sided lunchbox for carrying a 6-pack of beer. Amazingly, that gets through airport security too. So that's what I gave the last time I did this presentation off of. If I left that in your office with this device, and this goes to the, consumer devices are great for leaving at companies and not caring if you lose them. So I have one of these that's partially reflashed so that it doesn't need to boot off of the network and has an SD card reader-writer in it and runs off a battery pack. So if I left a lunchbox with 2 of these in your office, you might not notice it for a while, and I could capture data and then get it back later, or just transmit it out since I've got Ethernet and Wi-Fi. So at a high level, it's bad. It's 30 bucks, lots of hardware. I'm going to throw these away. I want to build one that I just duct tape to the bottom of somebody's car, let it drive around, capture packets, and transmit when it's actually got a stable connection. And I don't care if it breaks or I get lost. Same thing, consumer device. Think about what you need to do in the design. Sign the boot images so nobody else can do it. In this case, the solution is a little bit simpler. Make your media network private and make sure nobody can run the bootloader. The reality is, fix the damn devices. And then I just, some other slides. This is the SD card enabled version with 40 wires that also made it through security amazingly. They looked at it 5 times though. So that's all I got for you unless there's any other questions. All right, thanks guys.